talk about that. What's the antiderivative of 3x squared? X cubed. And how do you check your answer to an antiderivative problem? Take the derivative. Could it have been x cubed plus 1 and had a derivative of 3x squared? Could it have been x cubed plus 2? Do we know what that constant might have been? We do not, and therefore there's that plus c. Now, that was nice, pretty princess, because the 3 was set up to be a known derivative. What if that had not been there? What's the antiderivative of x cubed? 1/4 x to the 4th. You raise it by 1, divide by the new. Would you agree that if you took the derivative on that, you would get x cubed? That all ringing a bell? Okay, cool. Sometimes you either have to do an actual rewrite or at least a mental rewrite. What's the antiderivative of 1 over x squared? Is it x cubed over 3? Is it 1 over x cubed? No. What's the mental rewrite? If you didn't try, you just rewrote it first. What is the power there? X to the negative 2. Now, whether you write that or not, I wouldn't count off if you didn't write that, if you jump straight to the answer. But at the very minimum, you should have that in your mind. What's the antiderivative of x to the negative 2? Negative x to the negative 1. I was wrong. You guys are very much awake. Well done. Okay. If you try that power rule to a special case, if you raise negative 1 by a power, you get x to the 0 divided by 0, which is just what the heck is happening. Well, that's actually not an actual derivative or antiderivative. We know that the antiderivative of that 1 over x case is natural log. The absolute value matters. What's the difference between natural log, no absolute value, and natural log, yes absolute value graphically, or domain? Here the domain is 0 to infinity, and here the domain is everything. Now, in the absence of information about the domain, I'd like to generate as much truth as possible, and so that's why we go with the absolute values, so that if there had been negatives, we are including them. Understood? Then there's obviously the known derivatives, e to the x and sine and cosine. That's a bit of a gotcha. Remember that you're talking antiderivatives, so the sign is opposite. Antiderivative of sine is cosine. Let's jump to, I'll come back to that right side in a second. Would you jump to techniques? Am I following? Are you seeing this? Okay, just to remind you of a few things. Again, this should be review. If you integrate a sum, is it the same as if you integrate separately, then add later? Is that a thing? That is a thing. Is that true for products? Can you break a product into 2 integrals? That is 100% not true. It's really easy to do a counterexample to that. Would this be equivalent to this? Surely not. You know the correct answer should be 1/5 x to the 5th, and yet that answer would yield 1/9 x to the 6th. Obviously, that's nonsense. It does not work. So no, it's not true. That's a not true. What about if you have the existence of a coefficient in front of a function? Are you allowed to bring that coefficient out front? You are. What if that part is a variable factor? Are you allowed to bring that out front? 100% no. You may not. Never, 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 never. You never bring a variable out front of the integral. What about a fraction where the sum is in the numerator? Is it mathematically sound to break it up into 2 fractions each over the denominator? Is that true? Yes. Is it true that if the sum is in the denominator, you can break it up separately? Is that a thing? Give me a numerical counterexample. 2 over 3 plus 5, I heard. Is that equal to 2 over 3 plus 2 over 5? It is not in any way, not at all. Maybe 2 over 1 plus 1 would have been easier to see, but it's not true, okay? So that's a no. That's no, no, no. If the sum's in the denominator, you may not split it, all right? Is this all coming back to you, people? Cool. Let's go to fractions. Let's keep rolling with fractions. This will start to venture into new territory, so be with me, please. This first case is easy. How would you integrate it? You would first split it using that idea of splitting a sum in the numerator into x plus 3 plus 1 over x. Then you would integrate, and your antiderivatives are 1/2 x squared plus 3x plus, love that you said absolute value, don't forget your c. All right, easy peasy. Now, oh, thank you. If you have a little rougher division, thanks, sir. Dividing by x is easy. Dividing by something besides x a little more. Now, unfortunately, you might not have learned this last year because it's not in the textbook, and I don't remember if I told Mr. Irister to get this in there or not. You cannot split this over x and over 1. And doing this, x squared over x plus 1 and 3x over x plus 1 is allowed, but not productive. There is this element of, okay, well, what do I do? And if it's the case that this is improper, and by improper, in algebra terms, I'm talking if the top is greater than or equal to the bottom, you must divide first. Now, you need to make the most of these practice problems because I said they're not in the book and I have to supplement them. So it would look something like this. I'm going to divide to find something mathematically equivalent that I can integrate. When you're dividing by x to the first, you have two choices. You could divide synthetically, or you could divide long division style, whichever you prefer. Do you have a preference? Synthetic. Remind me of the algorithm or the process for synthetic. What goes in the quote-unquote box? 1 or negative 1? Negative 1. It's the 0 of the denominator, not the added number. It's the 0 of the denominator. The numerator. What are my coefficients in the numerator? Actually, I just told you. They're the coefficients and the numerator. Shut up, Corey. Just put the numbers here. 1, 3, 1. All right. The coefficients of the, what is that called? Dividend? Yeah, dividend. The coefficients of the dividend go up there. Remind me now of the process. Go. Bring down the 1 and write it there. Then what? You multiply the numbers here by that divisor, negative 1, and you record it there. And then what do? You add those two and record it, and then again multiply. Does that ring a bell? Okay. Now that's just stripping off the variables. Now we're going to bring the variables back. This tells me that this expression is mathematically equivalent to what? X plus 2 plus or minus 1 over x plus 1. Integrate that with respect to x. Okay? I'll talk about that real quick here. Some students are tempted to leave that off. They think, oh, what's the difference? Well, it's a huge difference. In Calc 3, you could integrate that with respect to z or something like that. The AP test is very generous in that they don't count off for a lack of differential. I assure you I will. I will count off every time I see it. It makes me sick to my stomach. Make sure you write the differential. All right? So what is the antiderivative of x, people? 1/2 x squared, the antiderivative of 2. Now this, it's quasi-function within a function, which might say u sub, but would you u sub that? What is it? Natural log of, okay, cool. What if your back of the book answer was plus log of 1 over x plus 1? Did you do it wrong? No. What did they do? They put the negative up and used a log rule, yeah? So be aware that's the thing. Okay, now let's go to that last one. I forgot these aren't on your paper, so I need a second to write it. Would you write the integral x squared plus 3x plus 1 over x squared plus 1? This is kind of jumping the gun. I didn't, that's all right, they'll segue fine. Yeah, it's fine. Quite, bless you. Whoa, that was good. Okay, so in this case then, Mr. Bell and I always had a fight over this. He would say, I would say you would not synthetically divide by this. And he would say, yeah, you can still synthetically divide by this. I think that's ridiculous. But if you did, what would you have to synthetically divide by? Plus or minus I, twice. It's a mess. I would never do that. Instead, long division it is. If this isn't linear, then I would suggest long division. I know it's been a while. It's not a one-off. You'll need to do that frequently in this class. So let's review. Don't forget, sometimes you'll need a placeholder. Are you tracking? Okay, you go leftward. So you say, how many times does x squared go into x squared? One time. And you write that above. Where particularly, I don't really care. I write it there. And then what do you do in the process? You multiply, record it here. And then, just like in normal numerical long division, you subtract, which is to say you change signs, draw the line. The first term should always zero out. That's the goal, is reworking rightward. So when you do that, you get plus 3x, and that's all, yeah? Okay. Now then, x squared does not go into 3x. That means that's my remainder. My remainder is 3x over x squared plus 1. Now we integrate 1 plus 3x over x squared plus 1. This actually is flowing beautifully. Loving it. Now, surely we can integrate 1 without any problem. It's x. But in integrating, I can split a sum up. I'm just going to split that up. In integrating 3x over x squared plus 1, next integration topic you learned last year. How do you do it? U sub, yeah. When you have a product where one's kind of powerwise the derivative of the other, you u sub it. So what is u? If u is x squared plus 1, then du is 2x dx. I think you'll agree you don't have 2x dx. So I don't know about Mr. Otterstetter, but I would divide that 2 over to get just the x dx. You follow? Which you do have. Now when I go to substitute, I have to count for everything. This x dx becomes du over 2. And the 1/2 I'm going to put out front because numerically I can do that. Likewise, the 3, I can put it out front as well. And so I will. And the 1 over x squared plus 1 becomes 1 over u. So my new integral, which should be easier to work with, that's the point, is 3/2 times the integral of 1 over u. Questions so far? So my antiderivative. Now, I will be happy to let you both anti-differentiate and sub back at the same time. If you want to anti-differentiate, keep the u, then sub in for u, that's fine. That's great. But on an AP test and on my test, if you integrated, BC kind of are cut a little more slack because they expect you to be brilliant. And so if you anti-differentiate and give me the answer, it is 3/2 x squared plus 1. Oops, I forgot the absolute value. Am I wrong? Why not? X squared plus 1 is positive anyway. So in this case, the absolute value wouldn't be doing anything. It wouldn't be wrong if you had it. Nobody count off of that. It's not really necessary. Understood? All right, cool. Let's go. Speaking of U sub then, would you jump down now down to a little U sub practice? Let me see that U sub skillage. Would you do those two? Check with your math amigos around you. And I'm going to hand out a few more papers.
Oh, I understand.
This looks wrong. So this will be tomorrow?
Yes.
Okay, so you're not Lucas?
Correct.
Okay, I just want to make sure. All right, cool. I'll be calling you Lucas the whole time. All right. You're welcome. You had a question on one of these. I wrote you another thing. I hope it's clear. And it is. How are we doing on the second one or done? On the first one. Hey. You're welcome. It's super important that you can do this well, so do ask questions, whether it be me or somebody around you. You're welcome. You're welcome. Kale, right? You're right. That's you, right, Joshua? There's another one, sorry. You're welcome.
I don't, it doesn't show.
Okay. Oh. So for the first one, are you feeling, let's go with just choosing between A and D. A and D, which one? D, because the antiderivative of sine, that which gives a derivative of sine would have been negative cosine, so it is D, yeah? Keep in mind that antiderivative. All right, cool. The other one was a little hairier. I had to play around with this. This definite integral rules also we need to get in here, but it's all good. It tells you what substitution to make. So just real quick, understanding why make that substitution. Imagine they didn't tell you what to do. Why would you make that substitution? Why did they do that? Imagine you had to integrate that. How would you have done it? I mean, you can't distribute. Do you agree? Because the sum is in the root, you can't distribute. There's nowhere to go with it. So besides a chain rule situation, which is the most common U sub situation, this is a derivative, one's the derivative of the other. That's a chain rule problem. That's the normal U sub. This is a smaller use of U sub, and it's when you get kind of stuck and you use U sub to move around the sum so you can distribute, right? So that's why they're doing that. When they make that substitution, it becomes this normal root U, which you could then distribute. What does x get changed to? If u is 2 minus x, then x is 2 minus u. Make sure that's in parentheses. What about always? One of the most common errors by far is blowing off the du. What is dx? Du or negative du? Negative du. There's a negative there. Okay, and you could put that negative out front. That's fine too. What about the bounds? Do they stay the same? They must change. If x is 1, then that implies u is 2 minus 1 or 1. If x is 3, that would imply u is 2 minus 3 or negative 1. Now, after substituting, that was what I had. Is that answer there? It is not. So, things. What do I do? Flip and negate. These, flip and negate. Why? Okay. What is, yeah, direction. What does du indicate? The change in u. And if you're going from 1 to negative 1, isn't that a backwards change? Yeah? And so you flip and negate because we're going to go forward from a negative. Now, if I flip those, negative 1 to 1, then with that negative, along with the negative out front, I get a big fat positive. And so you should be choosing negative 1 to 1 of 2 minus u root u du, which is E, Edgar? Cool. All right. Questions on U sub? Go back up to the top. I am giving you the antiderivative of tangent. Prove it. Find the antiderivative of tangent. Oh, this is on the homework? Let's do that instead. Forget that. That's already on there. Go to the homework. And what box we talking about, Hook? 4. Hey, do 4 in the homework. Why not just do that now? Good idea. A great multiple choice would be secant squared. Is it secant squared? No, that's not the antiderivative of tangent. That's the derivative of tangent. Classic trap, gotcha.
Just grab all of this over.
If you let u equal sign, wouldn't your du then be in the denominator? Du is never in the denominator, ever. did you get? Negative log of the absolute value of cosine. Yes? Okay, now that is not the more common form you'd see. You wouldn't see that in the back of the book, nor would you see that in a multiple choice. It is, however, equivalent to if you put this -1 up. Now that notation is always a gotcha. Is that -1 for exponent or -1 for inverse? Exponent. And so is cosine to the negative first power, is that secant or arccosine? Secant. It's secant. And so the common form is log of secant. That's what you'd see in a text. I'll take either. They're mathematically equivalent. But in terms of multiple choice, you need to be aware. All right. That said, you should be good there. Let's go back to the notes now. We'll come back. We're going to do some of those off the homework. But I want to make sure we're cool. I did this. Let's go. This also is u sub then. You could do cotangent by the same cosine over sine u sub kind of approach. But there's no negative there. Let's jump to these two. Did you recall learning those two famous antiderivatives? 1 over x squared plus 1 and 1 over root 1 minus x squared. So those, they might have been at the end of last year. Have you seen that? Okay. Arctangent of x plus c and arcsine of x plus c. You're going to need to commit those to memory. And we're going to use them a lot. And here we go. Jump down with that to a little more ugly, like this. Is this still in the front? Or is this the back now? Do you see arcsine, arctangent with u sub? Is that somewhere? All right, cool. Now, so you don't have to keep writing this or flipping over and back. This is the typical template for arcsine. If you see a root and a difference of squares, then think arcsine. If you see no root and sum of squares, oops, I'm going to call that u squared, think arctangent. Now, unfortunately, it's not just that and nothing else. There's other stuff going on. So this whole backside will be, all right, what happens when there's a little more going on? Here goes. This, at the very least, understand the smallest difference in the problem makes a total difference in the approach. What if there were an x up there? What would you do? It's u sub because the power works for the du. You did? But because there's not an x up there, it is not u sub. Instead, it's a totally different approach. And you say, well, it kind of looks like arcsine, but there's a lot of differences. We're going to make it look like arcsine, do a little u sub, make our life easy. Here goes. The first thing you do is you make the 1. Now, what's in that 1's place here is a 4, and that's bad. We're going to make it a 1. I'm going to show this slowly in 2 steps. But when you get to the homework, you'll cut this down to 1. If I factor out a 4, I have to do it from both terms. And then if I take out that square root of 4, then I'd have a 3/2 if I take the 3 out as well. 1 dx over the square root of 1 minus 9/4 x squared. Do you see where I'm coming from? Okay. Now I'm going to sub. If I'm going to fit this pattern here, it seems like u squared is 9/4 x squared. And if u squared is 9/4 x squared, then I will need to know what u is. What's u? 3/2. We're not going to worry about the plus or minus in this case because I'm going to sub back anyway. 3/2 x. I also, like always in u sub, I need du. What's du? 3/2 dx. Now, I actually, normally I'd say, all right, I don't have that, so I'll move it. But I actually do have, in this case, I do have 3/2. You follow? All right, so that's lovely. If I then make the substitution, I get the 3/2 dx becoming just a straight up 1 du. And the bottom, root of 1 minus 9/4 x squared, becomes the root of 1 minus u squared. And the 3/2 went away by virtue of being my du. Bless you. Are you all with me? Okay, so what's the antiderivative? Arc sine of u plus c. There is no absolute value here. Sometimes the people, that's another thing. Okay, and then you sub back. Arc sine of 3/2 x plus c. That's your answer. You try the one off to the side. It's a little easier because arctangent doesn't involve the square root nor negative. So I think you'll find it easier, but your goal is first to make the 1 first. I do have an 84. Oops, dang it, I already made it. Feel free to check with the people around you. Now this time, if you jump back to sub back for you after you anti-differentiate, that's the same. So I'm cool. If you have, do you have 3/2 arctangent of 2/3 x plus c? Anybody disagree? Have a question about what I did? Do it a different way, I suppose is possible, but not likely. We good? All right, excellent. Let's jump to, all right, great. What if it's not a perfect sum of squares or difference of squares? What do? Well, if you don't get a sum of squares, you make one. You make one. All right. And so look at this case. Is this following along the next place in the notes? Are we good? All right. Now, this is not your typical arctangent situation because it's not a sum of squares. We're going to make it a sum of squares by completing the square. I will leave the x's, but I'll kick off the 10 to the side, still in the denominator. But I'm going to replace it with my own thing. What goes in that space? What's the rule for completing the square to make a perfect square? Divide the x coefficient by 2 and square. So half of 6 is 3, squared is 9. Now we have two ways of balancing in math. You could do to both sides or do and undo. Yeah? Now I can't do to both sides because there is no both sides. So it's going to have to be do and undo. So to balance adding 9, I subtract 9. I think we can agree that mathematically this is totally equivalent to the original problem. There is no reason I can't do that. Okay? Now then, the reason that helps me is now I can write it as a perfect square. They don't call it completing the square for a reason, for no reason. This is the square of x minus 3 plus 1. Now, I guess you could use sub this, but there's not a lot going on with that x minus 3 just subtracting 3, so I wouldn't use sub this. I just go to the answer. What is it? Arctangent of x minus 3 plus c. Now, if it was arctangent of 3 minus x, well, then I'd probably use sub it because that negative in there makes my du change. But I think I'd go with it. You try the one to the right, please. You try the one to the right. This mine or this one is? Okay, let's go to 13 on the homework. Way to go, Dylan. I don't know if that was my intention, but good job. Way to foil me. That's, I'm telling you, well, both. I should have changed it, but I didn't. So now you're going to change it. Yeah, we don't, you guys haven't learned that yet. So there's a way to do it. Just haven't learned it. Did you get arctangent of x plus 2 plus c? Any disagreement, questions? Are we good? Before we get harder, I need to make sure you're good with me so far. You good? Okay, cool. Going back to the notes, uglier case. Those were what I would consider easy because after the stuff you had a 1 there. Sometimes it's not so pretty, princess. And so here we go, putting those two skills we just practiced together. Say I completed the square here. X squared plus 4x, leave a space, plus 7, leave a space. What goes there? Plus 4 minus 4. So now your new integral equivalent is 2 times the square of x plus 2 plus 3 dx. All right. Now, using the previous skill, what do we need to do? Make the 1. We need to make the 1. So we're going to factor out a 3. And out front, we'll have the 2 and the 3. And inside, it'll be 1 over x plus 2 squared over 3 plus 1. What? Oh. Lucas Lawrence in the front right there. Just messing. Hi. All right. Here we go. Oh, dang it. My bad. Darn lack of coordination. U squared is x plus 2 squared. Is that a 3? Yeah. X plus 2 squared over 3. U is x plus 2 over root 3. Now we're getting in the sloppy territory. What's du? Consider that if you put that separately, wouldn't it be 1 over root 3 dx? What's the derivative of 1 over root 3 dx? 1 over root 3. Yeah? Oh, sorry. No wonder you're confused. It would be 1 over root 3 x. And therefore, the derivative is, I misspoke, sorry. 1 over root 3 dx. And so with substitution, I get 2/3 1 over root 3. No, that root 3, when I move it over, becomes root 3 in the numerator, is it not? Okay, so root 3 integral of 1 over u squared plus 1 du. So all said and done, my answer is 2 3 over 3, arctangent, not sine, of what was u, not u squared now, look at u, x plus 2 over root 3, and thankfully in calculus we don't really care about a root in the denominator, nobody cares, all right? Is this one also on the homework? or something. Should we just do one off the homework? What do you say? Okay, let me find one that's ugly like that, and I'm feeling number. Oh, that's the mother. No, that's not good. Do I not have this? I don't know if I have one. That guy? No, it's good. Sorry, I apologize. I guess you're just going to have to do it in your notes. You did need to practice it. Try that one in your notes. Sorry. Take attendance. All right. Okay. How are we feeling about 2 root 5 over 5, arctangent of x minus 5 over root 5 plus c senor? How do we do? Excellent. Last but not least, a little bit of fundamental theorem. We did a definite integral already, but just to remind you, indefinite integrals really just mean take the antiderivative, call it good. Definite integrals have a million layers of meaning. I could talk about the fundamental theorem for at least 3 hours, I'm sure. But for now, I'll just go with a big idea. If you talked about integrating a rate of change, the area under that curve would represent the amount of change. And so I'm going to say that right here. Integrating a rate of change gives amount of change. This refers more to this form of the FTC. Integrating a rate of change represents amount of change. We'll do applications more next week, but for now, have that in your brain. Would you show me your, actually, let's make sure you're clear. I require you to show the antiderivative anytime you do a definite integral. What's the antiderivative? X to the negative 4 over 4 or x to the 4th over 4? What is it? X to the negative, raise it by 1, divide by the new. So x to the negative 2 over negative 2 or 1 over negative 2x squared, yeah? From 1 to 3. What do we substitute in first, 3 or 1? 3. So negative 1 over 2 times 3 squared minus negative 1 over 2 times 1 squared. Yeah? What is negative 1 over 2 times 3 squared? Negative 1/18 plus 1 over 2. What's our answer? It is A, B, C, or D? D. It's negative 1/18 plus 9/18 is 8/18. 8/18 reduced to 4/9. We? Okay, okay. Good stuff. Now, in order to practice, do a few more of these off the homework. Would you do numbers 2, circle these please, 2, 9, and 11 and 12? Sorry, 11, 12, and 14. It looks like 1, but it's actually 11. I'll say that again. Actually, I'll write it here. Can you tell me, what were those I said? 2? 11, 12, 14. Okay, but the 11 looks like a 1, actually. Feel free to talk those over with your math amigos.